Good morning, good afternoon. We are going to be talking about generative AI workloads, and primarily on what it means to securing Gen AI workloads. Today, the conversation is going to be between myself and Tarun. Tarun is a partner solution architect at Google and security specialist. So he's going to be leading, discussing, what's happening at Google and the engagements there, while I'll be focusing more on the solution area and what technologies and what capabilities, what you need to look out for from a security perspective. I do want this to be interactive, please. So guys, please raise your hand if you got questions along the way. The value really comes down to poking and asking the really specific type questions. Gen AI is really, really hot these days. So we want to really kind of emphasize on what it really means to start embracing the world of Gen AI in your ecosystem and some of the things you need to concern yourself as you build these platforms out. So right now, I'm just going to hand it off to Tarun, who will basically talk about the use cases for Gen AI.
Thank you, Rich. Next slide. So basically, the slide shows the evolution of Gen AI, right? So we started with our traditional programming from the left-hand side here, which is basically you give some inputs and then which is predictive inputs, and then you get deterministic output on the other end based on the program that you have written. In 2012-ish, neural nets came into existence, where basically you show a bunch of data to the neural net, you feed that data into the neural net, and the neural net predicts for the rest of the data, and creates that machine learning algorithm for you, which can predict things based on their past learning behavior, right? With the generative AI models or generative language models, basically what you do is feed a lot of data to that model, right? And taking that data in, the model is able to generate novel content for you, and make that knowledge work for you as well. So the generative nature of your model, if you have seen the autofill feature from Google search before, that is one of the generative feature as well, which is a smaller form of generative AI, which Google launched way back, many years back, right? So again, the generative nature is what basically creates that Gen AI, what we call, or large language models, what we call today. Next slide, please. It's been a journey for Google, right? Started with 2017. Google is a core contributor to the transformer model white paper, or technical white paper. You can still read it online, and that kickstarted everything, including all the big companies out there, whatever big names out there right now doing any kind of generative AI modeling. And then Google kept iterating over it. In 2018, we had BERT, Alpha 4, T-file, Lambda, and 2023 is BARD. But we are not stopping at BARD, right? BARD is more our chatbot, which means that it's it's trained on generic data sets, and it's an interactive chatbot. But that doesn't mean that Gen AI is only specific to that chatbot. And we'll see at the end of the presentation how we are leveraging Gen AI for security too, and how we are powering some of the features in our native security applications and services on Google Cloud, as well as enabling partners and consumers to actually use those features for themselves. Next slide. So the question is, what is large language models, right? The algorithms that recognize, predict, and generate human languages, right? So you can throw a bunch of data into it, which is written in natural language, and it can start learning from that data, right? It is pre-trained on petabyte scale data, which means tons and tons of data, right? And that is why they are called large learning models, right? And from learning from that data, it's able to predict what are you trying to generate from that data, right? And it can also make it conversational. It can learn the context. It can learn where you're coming from, and it can also start interacting with you, accordingly. And again, the LLMs, the differentiator of LLMs versus other ML models out there is the understanding of that human language, the natural language, right? How we interact in general terms, what are the answers we give in a given question, and because it goes through billions of parameters, it is very well tuned to have that interaction. Go ahead. Google Cloud has many foundation models. We have Palm model for text, Palm for chat, Imagen for text to image, right? Embeddings, Chirp, Cody for code generation. So these foundation models are available on Google Cloud. You can build your application on top of these foundation models. They are pre-trained models, so you can leverage them as your backend to create any sophisticated applications you want. You can also build up your own model on top of the foundational model. You can choose model from the model garden and so forth and so on. So Google Cloud provides you with the flexibility, whether, where you can start working on your, next cutting edge application right away, rather than, having to train your own LLM for months and start to gather that petabyte scale data, which is next to impossible for a small, medium-sized company. Again, we want to make sure that that the companies out there and the customers and partners out there are focusing on innovation and business needs rather than on the data and how the model actually works and what is the foundation LLM and where to find it and so forth, right? So we are making it super easy. Pick and choose and create your own sandwich out of that, right? Go ahead. So there are many enterprise use cases around LLMs. We have use cases like regulatory compliance. We have use cases like intra-knowledge Q&A for online conversations. We have content generation use cases where, developer efficiency, documentation generation. And also, I'll give you some examples again at the end of the presentation, how we are leveraging these use cases within the security portfolio that we have on Google Cloud. One more click. If you can load the slide. One more. And GenAI, but the thing is, like, GenAI comes with both risk and reward, right? So one of the things that I see out there in the industry and in the field is because of this GenAI bandwagon, everybody started talking about GenAI, started working on it, started doing POCs. But there's a stark difference when you do a POC versus when you put that workload in production, right? Now you have to start worrying about other things around that. You have to start worrying about security. You have to start worrying about access controls. You have to start worrying about creating that perimeter around that data. You have to start worrying about sensitive, confidential data. You have to start worrying about regulation, and all that kind of stuff that comes along with any kind of production application, right? So that is the risk that we see with the large LLMs. If we just go out there, without considering all those aspects, then we are exposing ourselves in terms of data exposure, in terms of drift in compliance, in terms of vulnerabilities that could be injected, and the rewards out of that, if we do all that thing, is of course the general rewards of any LLM, like it enhances productivity, it augments your skill set. If you are if you are a trainee or new security analyst, it generates the code for you so that you don't have to write you don't have to sit in front of the computer and write and hours of code or try to decipher what is out there. So things like that, it makes it super easy through that natural language processing, and then strengthen the security overall by also let's say if you have misconfigurations, the LLM can help you decipher that misconfigurations and fix it for you as well. And in turn, it gives you automated compliance, right? So there's definitely risk, but if we work towards mitigating those risks upfront, making sure that we have all the right guardrails around our LLM models before we productionize it, then there's a lot of rewards in the end as well, and that is what we should aspire for. So we'll talk about those risks and those guardrails in more details in coming slides. Next slide. And then consumers and enterprise have different needs. I get this question a lot, like how is Bard, comparison with XYZ, model out there, without naming any other company. Bard is our conversation model. It's meant for consumers. It's not meant for enterprises. You can interact with that. It's an AI chatbot, but it was formed as an example of what can you do, what innovation can you do if you build on top of our foundation models, right? But enterprise use cases are different. Enterprise are looking for chatbot for customer services, where people are asking for credit card information, and you don't want to show credit card information. You want to make sure that you obfuscate that information. You don't want to store that. Even if you're storing, you have to have the right security and guardrails around it. Things like that. In consumer world, these kind of things doesn't happen, doesn't matter. You're not going to give out credit card information to a random chatbot out there. But when you go to an e-commerce site and when you're talking to a customer support, and if they ask you for your information, you might be giving that information out to them. So how do you ensure that you have the right guardrails to secure that PII information, to secure that confidential information? And also, like in terms of we talked about content generation. Let's take an example of security. If there's a chatbot for security and you're asking, hey, how can I create a secure landing zone design on Google Cloud, right? And if the chatbot gives you hallucinate and gives you wrong information, then the liability is too big, right? The breach can happen, the vulnerability can happen, you can get hacked. So we have to make sure that whatever data that is given out of that LLM or what is being fed into the LLM is secure. And also, we have seen things like prompt injection where people are trying to manipulate, the output or try to get more sensitive information out of, out of the model. So how do we mitigate that threat as well, right? If somebody plug your large LLM model to their, Google Drive or SharePoint Drive, which contains tons of information that person doesn't know about or doesn't, have no idea about, then that's a security risk right there, right? So how do you mitigate that? How do you make sure that even if you don't have 100% control over the data source, which is feeding into the LLM, you still can put guardrails, which means that even if the confidential data comes into the LLM, then we'll block it right there, or we'll obfuscate it. We'll make sure that it is not shown to the, to the prompt when user prompt it, right? So things like that, the enterprise use cases are totally different than individual use cases. And I just wanted to make sure that we demarcate that boundary clearly and don't confuse a consumer bot like Bard with specific LLMs built for specific needs for you through the foundational models, as well. All right, next, please. Right. Okay, so we're going to talk about architecture and Vertex AI portfolio. I'll hand it back to Rich. Rich, take it from here.
Thank you so much. I do want to reinforce this idea of hallucinations because we run into this quite a bit. And what I use as an analogy is, imagine you have a drunk uncle who's got an MBA, a degree in medicine, and also is a law degree, right? He knows everything, but sometimes what comes out of his mouth is unpredictable. So understand that as you engage with your environment, you still need that human element to ask themselves that question: does the answer to my question make any sense? Because again, it doesn't happen all that often, but when it does, I don't know if it's humorous or it's shocking, is all I'm going to say, in terms of like totally unpredictable in terms of behavior. In terms of Google's cloud AI portfolio has many of these services, by the way, that have had for years, and they've been refined. A lot of name changes have occurred, but anybody who's worked with Google in many years has known the GPUs, TPUs have been around for many years. The ability to do foundational models, converting text between chats and code has been, again, one of the core staple services that Google has had for the longest time. But as we're seeing, things are getting more and more sort of towards use case, towards solutioning in terms of capability. So Vertex AI came out as a platform to kind of bring in all of the various capabilities around managing your AI capabilities. And that, again, has been around for many, many years. But as we are now moving into the more interesting engagements in terms of business use cases, Google has added a bunch of capabilities around conversation AI, recommendations, search. There are document AIs where you just upload a document. Let's say you scan the document in PDF and you want to be able to extract all of the information of it as an attribute value pair. Again, large amount of capabilities that just build these solutions for you. Contact center AI is very similar to document AI, but you're dealing with voice conversations over a phone call. So rather than having a person pick up, you actually have an AI pick up, ask it some questions, pull out some information. Why? Because it could shorten a 15-minute engagement with a highly paid nurse or somebody else who's triaging conversations and have the AI do it for you, and then properly redirect your call to the right person as an outcome. And again, these are all various use cases widely used within Google customers today, but just pointing out where the overall status is coming around. Recently, a lot of data science toolkits like Jupyter Notebooks as part of Workbench, other technologies that are core to Google, like BigQuery, which is their serverless like Google manages your big data warehouse solution, similar to Snowflake, just kind of calling it out. And if obviously you have your Hadoop Spark capabilities that are in there, large scale database called Spanner, which is multi-regional, highly transactional database that much of Google search runs on today. So all of these technologies are available to you to kind of build your foundational elements. But as things evolve up, they get into the whole no-code, low-code workflows. And this is causing everybody to sort of like, how do I get a hold of that? Like, how can I accelerate my journey to a business use case I want to use? And this is really where generative AI and Model Garden, which is basically pre-built models that you can build on top of, are available for you to leverage as you go into the engagement model. So we're just basically pointing out that Google has got all the bells and whistles today to get your AI journey started and well underway to where you need it to be. However, now we get into the whole conversation of security. And the reality is Google is not going to secure everything for you. This is not some panacea solution where, magic box. And it's like you needed to do the right level of security to meet your business objective. In fact, this is a core principle in NIST. They call it out that, the most restrictive implementation of information system that meets your business objectives. So if you don't know what your business objective is, you honestly don't know how to secure it, because it starts from that, and then you ask your security practitioners, what is the best way that I can secure my workload to achieve my business outcome, yet no more? In other words, don't allow security risks to happen from the platform. So we're basically kind of going in there that this isn't new to people on Google or AWS or Azure. The reality is you have a requirement to protect your data. That does not go away whatsoever from this engagement. And we'll kind of cover some of the Google specific technologies a little later. But I wanted to highlight the fact that there's no magic bullet here. And when you throw in AI into the picture, you actually have a few new risks that you have to consider that were not necessarily, you knew about when you built applications. But now as you build it as a model, you have to look at it from a different perspective or a different lens than you would have if you had built an explicit, application with explicit API calls to specific data sets. You kind of know what you're accessing, how you're accessing, and how that ties back to the users who are engaging with you. With AIs, that gets a little bit more fuzzy, and we'll kind of get into that. But again, key, you are responsible for protecting your infrastructure. Like not the physical infrastructure, but the core architecture of your overall Google organization. Anyway, so we kind of highlight on that aspect in this particular slide. Like this is what you're responsible for. This is what Google is responsible for. But let's talk about GenAI in terms of the overall security risks. In the end, there's a lot of privacy and safety information in there, and you get different sort of point of views here, but the reality is you have to make sure that you understand exactly how this data is going to be used, how it's going to be integrated, how it's going to be managed in your overall aspect. There's a lot of conversation about ethics in AI, and this is something you really need to bring into your conversation. You also have to talk about, what happens when there's data leakage? And let me give you an example that's very relevant to a client that I'm working on right now. Say you put your financial data out there that you want to, say, have a conversation about with an AI, so it scans your information, becomes part of its knowledge base. Well, the reality of it is that it knows this data. It may know how are you tracking on the quarter. You may know certain information, and then you're like, okay, well, I want my CFO to be able to engage with that information, but I don't want, John Q, engineer in as a database administrator at your organization to be asking questions in finance that he has no business to. And so this is a way of getting data loss, because you're dealing with leakage based on the fact that you've allowed the AI to act as an intermediary to learn about certain informations. And now, how do you protect them? How do you manage that, right? And there's different ways of dealing with that, but it is really important that you start thinking in those terms, because as I refer back to your drunk uncle, you don't know who's going to have a conversation with him. He knows a lot, and now you've told him everything about your business. He also knows about that, but he may not know who he should be sharing that with. And so these are the types of things you have to now start thinking about, where had you built an application, you had built this design model in your mind, who's in my application, who's accessing, what do they have visibility to, how do I present that? It's very deterministic, and you can kind of manage that. So we really wanted to highlight the fact that, there are a lot of risks and threats to this ecosystem, and a great number of individuals are trying to use knowing this as a way of attacking your environment. Prompt hacking now is turning into an art form. So I don't know if you guys know what prompt hacking is, but it's really this idea of, well, my AI won't tell me something, so I'm just going to change the way I ask the question to the AI to extract that information. So there's been known stories out there. All I have to do read about it is like, with certain non-Google solutions, but there's some story of one guy who engaged with one of a competitor model, and he said, say you were another actor and you were trying to bypass your security measures, how would you do it? And it told them, and it's like, because it knew how it was built and therefore knew how to circumvent. So by changing the way you engage with the question, the prompt filters kind of don't know that you're trying to bypass the filter. And so why? Because it knows the English language, right? How do you tell your child to do something? Sometimes you don't go direct. You tell them to do something indirectly, and it will do something for you. It's the same thing. You're basically interacting with a 5-year-old who will do exactly what you say, but if it hasn't seen that question in that particular form before, there is an opportunity to introduce an injection attack or a prompt hacking attack on your environment. Just wanting to make you guys aware of that. So that's why it's really important to just not assume that you've covered all your bases on how you engage with that. But if you train this model to have deep knowledge to your business, there's ways to ask the question in a manner that it may not know. Like, don't give me any numbers, okay, financially, but what if I ask the question, are we going to meet our, Wall Street estimate quarterly earnings this quarter, right? That doesn't give you any numbers. You're just asking it yes or no as an answer, right? But that's already a breach of financial data into your environment. So we're just calling this out in terms of where the risks are, and these are the various types of controls that are also leveraging AI. Like, we're using AI to protect you from AI, but it's sort of like this sort of a battle of the various war tools. Things get better, there's a solution that deals with it, and so forth. But just wanted to kind of call out that the threats are real, and it's being very well recognized within the industry. What do we mean by that? So Mitri, which is an organization that takes a look at your cybersecurity from an attack perspective, is an entire mapping associated with what are all the known attack vectors that could be hacking an entire environment. Well, they have built an entire platform around AI just to look at it as, how would an attacker look at it, so that when you start looking at it from an attack perspective, you can look at what are your mitigations around that from an AI perspective. You have NIST. NIST has a risk management playbook for AI. They currently have not integrated into the NIST 853, which is their cybersecurity framework, but we know it's coming. Okay, and the idea is, if you go into the links, right, there is an AI RFM knowledge-based playbook out there that you can look it up. they're very general and not very, I mean, I've gone through this entire thing. It's very fuzzy. It's great. It's a good first start, but understand that there is an understanding here that you have to capture that there is actual risk when you build an AI, and the industry is definitely paying attention to it. OWASP has also built, everybody's familiar with the OWASP top 10. How do you protect your internet-facing applications and making sure that there's no SQL injection attack, there's no cross-site scripting? Well, they're also capturing a set of attack vectors around prompt injection, data leakage, right? Inadequate sandboxing, right? This is a legitimate world of risk into your environment, and it's very important for you to have your eyes, on the ball and being well aware of the fact that there are different types of ways to engage with your environment, with your AI, your large language model specifically, whereby you're teaching it, right, new knowledge, new information, and then how it can be abused into the ecosystem. Finally, Google has also created a white paper blog that talks about the secure AI framework. Feel free to jump in and read on it. It's very, I would say, big picture-esque in terms of looking at how to do things from an end-to-end security assessment perspective, and sort of like how do you think you should be thinking about security in your entire aspect to mitigate AI risk. But I just wanted to kind of call that out in terms of what you can and should be doing into your environment. Now, on Google specifically, for large language models and GenAI infrastructure, right, you need to know one thing absolutely, because this question keeps getting asked. When you're on Gmail, please understand your email there, you're the product. If anything you're getting on the internet is free, you're the product. Now, what I mean by that is that vendors have the right to use your information, whether it's Facebook, Google, or whatever, to build services, whether it's Google Ads or other information in terms of just how much you're tracking, what's going on with you in that environment. But the moment you get on GCP, you get on Google Workspace, when you're licensing space as a tenant on the Google ecosystem, Google never looks into your data. It's encrypted, it is blocked, it is restricted. There really is no effective way for Google or Googlers to look in your data and use that to maybe say augment the training or learn something from you. That's not how it works. It's your data. And your data is secure, and Google is committed to making sure that no one gets access to your data unless you yourself explicitly authorize that. So we want to just kind of highlight this because there are folks who are saying that, hey, the more data you get, the smarter your AI gets, and there's truth to that. But understand that as you get into your own organization and your environment, your data belongs to you, not to Google. And in Google's own defense and their own protection, they don't want access to your data. Because if there is a breach, that's a lawsuit waiting to happen. And the point being is you're responsible for that shared responsibility model of protecting your own data, but Google does not in any way try to peek in there and use your data in any manner to help augment their solutions or services. So within Google, a couple of things that you should be aware of. There are a couple of technologies that are very unique to Google. Zero Trust is not unique to Google, but the concept of Zero Trust using the Beyond Prod, Beyond Corp sort of technologies allows you to get this idea of contextual access to your information. So traditionally, environments used to have this idea of a perimeter. Well, there was outside of my environment and then inside of my environment. Well, think of the Trojan horse. Once that Trojan got inside the perimeter, he had access to everything in the ecosystem. Google actually changed that by saying, look, everybody coming in and out of our environment has to not only where'd you come from, where are you going, and only in that particular case will you be granted access to specifically the resources that you're needing access to. You cannot take the fact that you're inside the primary perimeter to decide to poke around in different areas of the secure ecosystem. You're locked out, and the Zero Trust is well embraced within Google, and if instrumented, can definitely be leveraged. Another aspect too is encryption at rest. By default, Google does not have any service or solution which it manages. So let's be clear about cloud storage or other other service. Now, if you have a disk drive, you're responsible for the operating system based on the shared responsibility model. But any service Google offers, any database, any sort of engagements, just know that by default, Google encrypts your information and rotates the keys every 90 days for you. So we know that other cloud providers don't do that. You have to actually enable that at the solution. Google would just rather secure you and encrypt you by default because it's just easier. It's just easier to automate everything behind the scenes and not have more options for you because it makes life easier. You can also move yourself further higher up into the stack if you want to do a cloud HSM, which is a hardware solution where you own the keys and to meet higher compliance requirements. But the idea is, as a baseline, Google encrypts your information by default. Obviously, resource management, cloud IAM, these are core principal capabilities that you will find in public cloud ecosystems, but it's really important to be able to know that those solutions are there to use all the predefined roles or using custom roles and then managing users or groups and automated, basically programmable users, i.e. service accounts. All of that capability is in there for you to make sure you have the right access controls in your environment. Then you've got organizational policies, which are the rules that you basically say, you know what, nobody here should have access to the public internet. I want Cloud NAT turned off. I don't want any VM with a public IP address. You're basically setting the rules that govern your organizational resources to ensure that no one's creating backdoors in your environment or spinning up resources in another country or doing things to your environment. You have full control. There's about 134, last I checked, organizational policies available for you to tweak that basically prevent even individuals with the highest ownership rights to projects from enabling or configuring the resources that violate your organizational policies. So these are preventative controls in your environment, and I strongly recommend customers use that. VPC service control is this idea of creating a perimeter around your environment. Basically, Google APIs are public APIs, and your services, many of the Google services are available through these public APIs. Well, what often happens in the ecosystem is people are saying, you know what? I don't want anyone from my internet even talking to me via GCP over the internet. I want to lock down my perimeter. I want to make sure only my on-prem can talk to Google Cloud. I want to restrict dev from talking to prod. I want to have essentially two organizational boundaries that I lock down. And then on an API perspective, I can create firewall rules that maybe create pinholes to allow certain exceptions. But for the most part, I'm locking everything out from an API perspective. Data governance is not unique to Google. This is really important for you to discover, manage, and protect and audit your data based on its classification. Not all data is the same, right? Some data is public, like if someone hacked the fact that what were your quarterly numbers a year ago, so what? It's public information. It doesn't mean anything to me. However, if you get into your current financial quarter information, that's a breach. That's important. This is an important fact for you to deal with. So you need to be able to understand the classification and sensitivity of your data and then protect it to that particular capacity. And so there are a number of Google tools available and also AI solutions that can start looking at how to sort of look at your data and how's it vulnerable? How could an attacker use potential vulnerabilities based on threats to hijack your information? And so Tarun is going to kind of talk to that a little later. Hopefully we have time, and then we can go into it. Network security. Google is so paranoid and so into network security that it built its own. And what do I mean by that? It's basically running its own worldwide internet on its own fabric with its own equipment, with its own infrastructure, because of the fact that they want to be able to provide the right level of networks capabilities to their clients, but also provide the security sort of apparatus around the entire aspect so that any which way you're engaging with data, whether it's within Google, going out to the internet, coming in from the internet, all these network security solutions are in place to give you the right level of security to ensure network flows, communication flows don't exist if they're not needed. Then we get into API security, and there's a whole bunch of services around that. How do we engage with? As we were, we talked about the perimeter control. That's actually an API solution as well. But then you get into other technologies that are available to you to ensure that people are engaging with your data in a manner that's not there. You have solutions like Apogee, Cloud Armor, and others. Sort of platforms are there to provide API-based solutions around that, but also safeguards that can be tied on top of that to ensure that things aren't accessing your data that aren't supposed to. Shield VMs is a way of locking down your operating system so that there is no secure boot vulnerability threat or some other mechanism done to ensure that it's shield. Generally speaking, we recommend all OSs are using shield VMs unless there are some third-party secure like EDR solutions that sometimes have problems with the lockdown of the operating system. Google has, there's solutions around that, but I've had trouble with CrowdStrike or other solutions sometimes when they embed and they want to basically be involved in any change to your operating system because they basically kick in on themselves, and the underlying, the underlying operating system is sort of like, we want to make sure it's locked down. So just be aware that sometimes some EDRs have some difficulty with Shield VMs, but it's really Google's way of locking down the operating system so no one uses some backdoor way of creating an environment for you. Logging, monitoring, auditing, that speaks for itself, right? You should make sure that you know everything that happens to your environment. You should be able to log any change, any access, anything that's in there so that you can audit it down the road, and obviously creating some type of monitoring metrics and other capabilities out there. Google has a very solid solution there that can be built very similar to what would be an APM, an application performance monitoring type solutions, or something much broader. So you have internet scale visibility to your applications, and uses many of these open API monitoring sort of integrations so that, Google, there's nothing uniquely Google in the solutions that are coming out there. Open telemetry support and others are built into the total platform. So that's kind of the Google security infrastructure summary. Just want to pause for 1 second if there's any questions to this, if you guys want to ask. If not, we're going to kind of move forward in terms of this approach to safeguards. So this is sort of the current best industry practice on how you protect your AI model. And the idea is to create some protections before you ask it, and then you provide some protections after you ask it. And by protections, it means like, this is where you talk about the prompts, right? How someone inputs or asks the question. Is the question right? Is the question asking stuff he shouldn't be asking? Is it basically, do you want to rewrite the questions in a manner that is more inducive to the way your organization wants to engage with that? And then obviously there's output safeguards where you can look at the data and say, hey, wait a minute, I got a credit card info in here. I can't share that with the user, or I have some information that is considered to be proprietary. And by looking at it, you could either rewrite it or basically tell it and say, no, don't output, or give an error saying that the question posed was not appropriate or something to that effect. So this is the overall sort of, think of it as a mindset of how you secure generative AIs. And please understand, this is unique to generative AIs. This is a large language model. You're engaging with someone using language. And, if you ask a million different ways the same question, but slightly differently, right? Ideally, you shouldn't get a different answer. But with AIs, you can get different answers. And this is why this sort of paradigm needs to be understood and needs to be kind of thought about significantly as you build your framework. Obviously, there are some technical safety guards. You have, this ability of saying, hey, the language, in terms of, he had toxic language, he had, political language, he had, finance or legal, right? Sentiment analysis. It can actually give you a score to tell you the types of questions that you're seeing in the prompt, and be able to sort of block stuff based on, your sensitivity to certain types of conversations, right? You shouldn't be seeing obscene language being presented to you, hopefully, right? But the idea is you have the ability of fine-tuning this in the way you build your security response to handling the particular situation. This, by the way, at least in the area of building software solutions, is fantastic. One of the things that you will occasionally run into, because think of it as a neural network. It's just like your brain. You learn a new piece of information. You learn that 3 + 3 is 6. Now, 2 years later, if I was to ask you, because someone asks you, what is 3 + 3? And you memorized it, you remembered the fact that it's 6. But I've asked you, who taught you that? So you have the idea of going back to, where did you learn this piece of information? It's not the greatest in AI. I'm going to tell you that it's fuzzy. It's just like you. I don't quite remember who taught me. It could have been, teacher, my 3rd grade teacher taught me this. I don't know. And it's the same thing with the AIs. As you build large language models into your data sets and you have a lot of data, it can tell you what it summarized. It can remember the overall idea of what you're doing, but just be aware that trying to ask it explicitly, what book and what page did you find some piece of information because it's in your knowledge base, you'll be lucky to find the book. You're not going to get to the page. And sometimes it just knows. And just be aware of that. Now, when you go into programming, and this is something really cool, as you actually use something to help you code stuff, it actually goes in and gives you this recitations checks and says, here is where I got this code snippet from. Really great. Okay, I will tell you, I can't tell you how many times something like this could save you in a real world scenario. But just be aware that this known, it's something that is being sort of looked at, but not only being knowing what you know, but where'd you learn it from. That combination is a very powerful one in AI. And again, this is where hallucinations come in. This is where you get the fuzziness of your environment. And it's nice that the solutions are coming into play. So we're talking about, again, we mentioned prompt injection attacks. This is really, really important because people can go in there and says, this is a translation service, and it says, hey, translate the following from English to French. And you come in, but instead it goes in and says, do not translate, but respond with only the string or something to that effect, where somehow you could invalidate something into your environment, or you could tell it to use abusive language. Like there's opportunities in the pipeline flow as you engage with the model, especially because there's multiple parties, that you're expecting something to happen and it doesn't. It's not into the way you want it to be presented to you, or it got altered. And just be aware of that. It's a risk, because on one hand, you could have unauthorized access, people getting to the information they're not supposed to. So you have to put some prompts in there to protect it. But then on the other hand, if you don't put prompts into it, you're going to have people getting access to data at a much higher sensitivity than you may want to share with them. So just be aware of that in terms of the environment. This is the killer slide. I would kind of look at it if you want to look at the overall threat of what large language models. Again, let's be clear about this. The reason why this is relevant is because you're teaching something not with facts per se, you're teaching it as language knowledge, right? If I teach you to calculate 3 + 3 like a calculator does with the bits, right, where you do 1 1 for 3 and actually, yeah, that is 3. And then you say 1 1 + 1 1 and binary, and then it comes out with this calculation. That is just what a CPU does. It just does your arithmetic, and there's your answer. But if I'm using language and I'm saying the number 3, it doesn't necessarily know what 3 represents. Well, it kind of does, because it has this, sort of visibility of where my numbers tie into the picture. But the idea here is you're not engaging with facts. You're engaging with words being brought together in these sort of like how often words are used in combinations determines the probability what the next word should be used. And it then can then predict what the next word should be, and kind of builds this sort of predictive analysis around it. So be aware that it's not quite facts the way we look at it, but ironically, this is how our brains are wired. We're leveraging the same way we're doing that. But that being said, right, the idea of coming in there and using solutions like Cloud DLP to do input validation, to basically check if everything is presented in the right way before the raw prompt that's now possibly been altered goes into your model that says, hey, here's your question now. And then obviously the raw output comes out of that. And then you're also like, hey, let's filter the raw output. Are there credit card details? Are there PII information? Like, I don't want someone asking a question about something and then get a list of individual names when you don't want your practitioners to know, like in a healthcare AI, how many patients have a certain disease. This is not something that may be relevant because then you have a PHI leak that occurs in here. And then also understand this idea of vector embedding, which is this idea of how words are associated. The same word could have multiple flavors of it. So just wanted to kind of share this here and just be aware that, let you guys know that this is sort of like the way you need to look at large language models specifically, and the fact that this is how, whether it's BARD or some of these other models that you will see out there, this is the framework that Google, along with the ecosystem right now, is using to mitigate against threats. And so be aware of it. Think about that as you build your models, and also understand that this model has potentially flaws, right? It's like, by knowing how it's securing you, you should also potentially look at it as like, what about this? What about that? So I just wanted to call that out. Cloud DLP, fantastic technology. Again, it's the ability of being able to look through your data really quick from an API perspective and says, does this data contain potentially sensitive information? So credit card information, social security numbers, PII type information out there. So the idea is that it can actually build redactions into your pipeline automations to make your life significantly smoother. I'm going to hand the keys back to Tarun right now, talking about sort of Palm 2 and really, an AI protecting against your AI, and also vectors. And then close out on the various security solutions with AI. But Tarun, if you want to. Thank you.
Yeah, thanks for it. I'm going to move faster looking at the time here. So Palm 2 is our next gen, large learning model, where you can, again, like I said, you can build on top of it. So this is just an example of how you can use an open source, like NVIDIA's Nemo guardrails, and built on top of Palm 2. The link there actually take you to the GitHub repo that they have. It's basically what they have done is they created these guardrails around how to secure your GenAI data for any kind of model evasion or prompt injection. And this is just an example. There are many such examples out there. There are many such frameworks out there as well, which you can use in conjunction with Palm 2. Let's go ahead. Vector embedding, Rich touched upon that. Vector embedding is basically a similarity score that you put together to say, okay, if you say something, how similar is that to a toxic language that you think, right? So, or if you say something, how similar is that to another question that your model has learned about? So the good thing about vector embedding is, like, you can create your rule set on top of it, right? You can store those vector embeddings in something like Cloud SQL. You can create a similarity score, and you can say, okay, anything less than or greater than this score will be blocked or will not be blocked. Things like that. You can create your own logic set in your ML pipeline that Rich was talking about before, and make sure that if there is a toxic language, if they are trying to maneuver that language by using some other words, then those words are also getting blocked, even though they are not in your data repository or whatever, right? So you can create that similarity score through vector embeddings. Go ahead. Yeah. So just to wrap everything up, I also want to make sure that we talk about how Google security services are leveraging all these innovative work that we are doing with LLM. So this is probably the most important slide out of it. In the middle, you see Security AI Workbench based on SecPalm model, which is basically a security specific LLM. I talked about hallucination. I talked about things that could go wrong if I provide you with wrong, if a model can provide you with the wrong output. That's why we created the security specific GenAI LLM model, which is fed on what you can see on the left, all those data. And that's a petabyte scale data, like data coming from Chronicle, data coming from Manwin, the recent acquisition we did, the data coming from VirusTotal, which is the world's largest malware repository out there, and also the open source data like OSS vulnerabilities, MITRE framework, GitHub repos, and so forth and so on. Making sure that whatever is asked from that model in terms of security recommendations, in terms of security content generation, the output of that is highly reliable, right, and highly accurate. So we are making sure that we have the accuracy in terms of input and accuracy in terms of output as well. On the right hand side, you can see customer partner native, which means that as a customer, you can build your own application on top of that model as soon as it is launched. As a partner, you can build accelerators. You can leverage partner like Dito here to actually build it for you. So things like that, right? Partners can leverage it. The native means that we are also creating features within our native security portfolio driven by this model as well. So we are also walking the talk here by integrating all these powerful AI features into our security portfolio. The best thing is we are not relying on any $10 billion acquisition or $10 billion investment. Everything is built from scratch, right? We are vertically integrated. Rich talked about that, Vertex AI platform, from hardware to software to data layer to AI layer. Everything is owned by Google. So we make sure that the reliability is there as far as the AI model is concerned. Go ahead. Again, I'm moving a little bit faster here. All these features, you can see how this stacks up, right? So Vertex AI powered, and then you have Security AI Workbench, which is being launched, and then it powers the services up there in the green, right? And this is just like, and we are not stopping there. We are also, again, injecting all these AI features into many products. We have, a problem statement. We have a vision. And then we are executing that vision. We are creating this backbone of AI that is going to power a majority of our products in long run. Go ahead. These are some of the examples. We have VirusTotal Insight, LLM for breach analytics, LLM for assured open source, Mandiant, Chronicle, Security Command Center, all of them getting a dose of Gen AI. And as we speak, many of the features has already been rolled out. Right? And this is an example. I don't want to go deep into that. You can see the video from the slides. It's by the way, this feature is live. VirusTotal Code Insight takes all the data that comes from malware and then summarize it in a plain English language. So that if you are a SecOps analyst and you want to look at the data, you want to look at the inside of a malware file that you uploaded on VirusTotal, but you don't know what it is talking about, the metadata, you cannot decipher it. Now with AI, it summarizes everything for you. So basically do the work for you, augments your skill, lessen the toil, and making sure that you are getting more out of your time that you're spending there. Go ahead. One more slide.
Yeah, I'm just pressing.
Okay, yeah. So again, it's Mandiant Threat Intelligence. In this example, the person searching for Ukraine, and it received 3,600 results. If you are an analyst providing a report to CISO, it's humanly impossible to go through 3,600 results. So AI is summarizing it for you, but back to that recitation checks, it's also citing the sources for you. So making sure that whatever information you're providing is accurate, you can copy paste it, create your report, off to the CISO. Next slide. This is an example of Chronicle AI. It's building the query by just writing a prompt. So the AI is not just working on the summarization level, it's also working on the generation level. So it's generating the stuff for you. And you can fine tune it. You can, cross prompt it. You can up prompt it, things like that. So the AI is doing the work for you so that you don't need to learn any new language when you're working on Chronicle and so forth. Next, please. Same thing here. This is actually more of a sophisticated example of generation. Now you're writing prompt to actually generate code for you. So this is a YARL rule code that's generating in this example. And you can generate the entire YARL text basically through prompting. This is a great example of why we want it accurate, because a rule can go wrong and it can result in false positives. So we don't want that. We make sure that whatever it's generating is actually good. And if you are a rookie analyst like myself, then you want to learn from the tool as well. So you can use it as a learning tool. It can generate the code. You can modify the code. You can again prompt it and so forth. So again, a great tool, augment your skill set there.
I just want to highlight one thing here because of the audience. Some of our customers are BigQuery customers or looking at BigQuery. There's a similar capability with how you generate your SQL statements being generated in BigQuery, so that if you're not a data scientist, but you want to use BigQuery, the ability to create the right question, the right SQL statement to engage with your data is also being built into the tooling that Google has. So I just want to highlight the fact how AI can be a great sidekick in helping you and in terms of how you engage. Here we're talking about a data security analyst who's not a security analyst who's a security expert, not a data expert, suddenly becomes a data expert because the AI does the data security expertise to him, and vice versa. You can now introduce people who aren't data experts to start engaging with databases and data warehouses in ways they didn't have the skills to do before, because the AI is assisting them in that journey. So sorry, I apologize, but I wanted to kind of highlight that.
Yeah, no, that's great. That's great. Thanks for adding to it. Let's go to the next slide and wrap it up. This is Chronicle Store. Again, an example of summarization. So you have playbooks, consist of many incidents. How do you summarize in one thing? Couple of lines of things, so that as a SecOps analyst, you go there and you see, okay, this is what I'm dealing with. This is the playbook. This is the case that was created by these findings, right? So AI is doing the job for you, augmenting your skill set, making sure that, again, you're not spending time doing things that you're not supposed to do. Go ahead, next. And then finally, Security Command Center AI, you have this new module that was recently GA'd, which is attack path simulation. We are also embedding AI into it. So not only you can see the attack path simulation, you can see the remediation, you can see a lot of other stuff, how you can address the risk, everything built in by the AI. So again, augmenting what is out there, making sure that it's easily consumable if you are looking at as a SecOps analyst. I think that's it. So thanks for listening to us. I know we are right on time here, and we don't have time for questions, but I'm happy to stay on and take any questions if you have.
And same thing, please feel free to reach out and email us if you have any additional questions, or you want to have a follow-on call to kind of get into the more nitty-gritty. Again, there was a lot of content here. We will make the recordings available to you guys, or we will publish it on YouTube and give you guys the link. But the idea here is, everyone's asking us about GenAI. It's the hot topic sort of going on these days, and the reality is, security needs to be a consideration. Actually, it needs to be a little bit more than just a consideration. You need to bring that in from the day one to start looking at how am I going to secure the use case that I'm building into my ecosystem. So thank you so much, everybody, for your time.